with this. Although this integral might seem like a long one, it's an indefinite one. We're just taking care of the antiderivative here. It has quite a long argument. We see sine x, cosine of 2x, plus cosine x, cosine 2x, minus 2 sine x, sine 2x. And one might start trying to factorize out something or find some complications. But the point is that one can just use this thing, although it's not just, it is a thing that's very useful. It's one of those integral identities that can be used in order to simplify the process of solving an integral by a realization. For example, this identity, what it talks about is when one has a function and its derivative added as follows. So it's a function plus whatever its derivative is, and all of that multiplied by e to the x, and that's the argument of an integral. It can be made equal to e to the x times the function, this f of x, this very f of x that was here, plus c as any integral, and any general antiderivative has plus c, of course. So this is the point. When one has inside the argument of an integral e to x times the parentheses inside which it is f of x plus the derivative of that f of x, one can just get the solution without having to apply any concrete integration techniques by knowing that this is proven to be equal to e to the x f of x. We might go into the proof in another video, but in this case I'm taking a look at the concrete example. And indeed, one might say, well, it's not really easy to know whenever you're faced with such an example that it will match exactly this, and in many cases it might seem like it does, then it turns out it does not. But in this concrete case it does, and therefore it's a nice example to show it with. So what we'll do, just to show and practice this technique, is I'll find the pattern. So we're suspecting that this integral will be of this form. There's e to the x, which is fulfilled, so this is right. And the rest, what I want to find is f of x plus f prime of x. Well, what I have to find is a function plus its derivative. Well, and what could that be? Well, for example, I can pick this as f of x. Maybe it is already that way. So if I say that this is f of x, then in such case, whatever is added, the rest of the parentheses, which is as a whole multiplied by this exponential e to the x, this thing has to be the derivative of this. So if I say this part is f of x, this has to be f prime of x. Well, the question is it so? Well, I can check it. And this will be derived using chain rule as well as product rule on the outer image. So it should be cosine x. We just take the derivative of this to check. So sine x cosine 2x, derived as a whole, d over dx. What is that? Well, we can use product rule from the outside, which is cosine x cosine 2x plus sine x times minus 2 sine x. All right. But this is minus 2 sine x as well. So just to be careful here, this is 2 sine 2x right here. And then if I modify this, well, it turns out to be cosine x cosine 2x here and here. And this minus 2 sine x sine 2x, which turns out to be exactly the thing we have to have inside this parentheses. So this is a concrete example of this very identity, and I can just apply it straight away. And what is the f of x? Well, f of x is what was guessed in the beginning, which is exactly sine x times cosine 2x. So this can be used in order to solve the integral. As you see, if you know the identity, and this is proven or shown or seen, found out to be exactly something that is an example of this, then it can be straight out used without any need to use any technique, any concrete technique, just be meshed on this expectation. So we expected that such an integral will have the solution e to the x times f of x, and the f of x is what was suspected to be f of x, namely sine x cosine of 2x right here. All right. And that is it, plus c. Alright, so just following this identity, when we found out that inside this integral we indeed have something that is f of x, then to it added something that is f prime of x, and then all of that is multiplied as a whole by e to the x, that can be set equal to e to the x times the f of x.